You know, whenever we hear about a humanitarian crisis, we get hit with this wave of just huge, almost unimaginable numbers. But what do they actually mean? Today we're going to learn the language of data to see the very human story that's hidden inside all those statistics. Okay, let's get into it.
So let's start with this number from a recent United Nations report on Somalia. 2.5 million. That's how many people are being affected by a severe drought right now. We're talking across 26 different districts. The scale is it's staggering.
And it doesn't stop there. Inside that bigger crisis, you have this story. Since just the beginning of this year, almost 142,000 people who were already displaced have been forcibly evicted from their temporary homes. You have to remember, every single one of those digits is a family losing the tiny bit of stability they had left.
And then there's this number, the one that kind of puts a wrench in everything. Of all the money that's needed to respond to this crisis in 2025, only 20% of it has actually come in. That leaves this massive, critical gap between what people desperately need and what can actually be done.
So you've got millions affected, hundreds of thousands displaced, and this huge funding shortfall. But they're just numbers on a screen, right? To go from just seeing these figures to actually understanding the situation on the ground, well, we need the right tools. The real question is, what are they?
Well, believe it or not, the answer is statistics. And I know, but it's not just about crunching numbers. It's this incredibly powerful toolkit for gathering, organizing, and really interpreting information so we can make smart decisions, especially when lives are on the line. So, let's open up the toolkit.
Think of it this way. Statistics really has two main jobs. The first is what we call descriptive. That's all about summarizing what we already know, basically the what happened. The second is inferential, and that's where we make educated guesses about the bigger picture from a smaller slice of data. It answers the question, what could this all mean?
Okay, but before we can even start doing any of that, we've got to get our house in order. The very first step is to figure out what kind of data we're even dealing with. Because you see, not all numbers are created equal, and knowing the difference is absolutely crucial.
So the first and most basic type is called nominal data. Really, all this is putting things into different buckets or categories. There's no natural order or ranking here. Like, think about blood groups. Group A isn't better or higher than Group B. They're just different labels, different categories. Simple as that.
Next up, we have ordinal data. Now with this one, the order definitely matters. If you rate your job satisfaction as a 5, that's clearly higher than a 4. But here's the catch. Is the difference in happiness between a 4 and a 5 the exact same as the difference between a 1 and a 2? Probably not. The ranks have an order, but the steps on that ladder aren't all the same size.
Then we get to interval data. Here, the steps on our ladder are perfectly evenly spaced. The jump from 10 to 20 degrees Celsius is exactly the same as the jump from 30 to 40 degrees. But, and this is the key part, there's no true zero. 0 degrees Celsius doesn't mean there's no temperature at all. It's just another point on the scale.
And that brings us to the top tier, the most powerful type of all, ratio data. This one has the whole shebang. It's got order, it's got equal intervals, and it has a true zero. A true zero means zero actually means nothing or the absence of something. This is what lets us say things like twice as much or half as many. With age, for example, someone who is 40 is, literally, twice as old as someone who is 20.
All right, so now we've got the lingo down, we know the different types of data, so let's take this brand new toolkit and get back to what's happening on the ground in Somalia and see how it helps us make sense of it all. Let's put this into practice. Look at this. When the report lists the names of affected districts like Zaylok or Lugaye, that's nominal data. They're just categories, right? But when it talks about goat prices dropping from $110 to $80, or the 2,109 cases of diphtheria, that's ratio data. It has a true zero, you can do math with it. Same goes for that 5% case fatality ratio. See how just classifying the data starts to bring some order to the chaos? And remember that 20% funding number we talked about? Well, here it is, laid out plain as day. This visual really drives home the reality of the situation. The required funding is over $1.4 billion, but the amount that's actually come in is just $284 million. Seeing those two bars next to each other makes that gap, well, it makes it impossible to ignore. This is descriptive statistics doing its job perfectly. Okay, so describing the problem is one thing. That's super important. But the whole point isn't just to describe, it's to act. And this is where we shift gears and start using the data to make those critical, life-saving decisions. This is the power of inference.
Look, it's just impossible for humanitarian teams to survey every single person in a crisis. So what do? They collect really detailed data from a sample, say a few of the hardest-hit villages. Then they use that information to draw conclusions, to infer what the needs are for the entire affected population.
And this isn't some new strategy they cooked up for emergencies. It's a fundamental concept in science and public health. This quote here reminds us that this method, drawing big conclusions about the whole from just a small part, is the gold standard for turning raw data into knowledge you can actually act on.
So what does this actually look like in the real world? How does it save lives? Well, by inferring the bigger needs from their sample data, aid workers can target food to the districts that are most at risk. They know to request specific medicines like diphtheria antitoxin. They can go to the world and make a powerful, data-backed case for more funding. And they can start to plan for what might happen next.
So let's tie this all together. We've kind of gone on this whole journey, right? From these confusing, overwhelming numbers to clear, concrete, life-saving actions. It all comes down to why this process, why the data matters so much.
It really boils down to this simple four-step journey. You start with the raw data. Then you use that statistical toolkit we talked about to give it some structure, to give it meaning. From that structure, you can infer what's needed for everyone. And then, and this is the most important part, you turn that understanding into action.
In the end, it's so important to remember that every single number in a report like this one represents a human life, a family, a community. The language of statistics, it's not just for academics. It's the tool that translates their needs into a plan. The data gives us the knowledge, but the real question it leaves us with